Mathematicians just discovered something incredible about pi. Something that completely challenges your intuitions about math in general, but is so satisfying once you understand it. If you stick around to the end of this video, I'm going to tell you what it is and why it really, really matters. So first, what is pi? Something to do with circles, right? Not exactly. You might remember pi from secondary school as the ratio of the circle's radius to its circumference. So if I divide the circumference by the radius, I get pi. Always, since this ratio is the same for all circles. That's what a circle kind of is. Sounds good, right? Well, not exactly. You might also remember that this number, pi, is infinite. Not infinitely large, obviously, but infinitely long. Irrational, meaning its decimal expansion, that's what we call its full number, goes on forever without ever repeating. Except for that doesn't make any sense. It's sort of obviously impossible. I mean, how could a number go on forever? Like, what would that even mean? Scientists and mathematicians since ancient Greco-Rome have puzzled over this frustrating problem. It clearly cannot be the case that pi is really irrational, but if it's not that, what simpler form can we find for it? There have been many attempts over the years to solve the pi problem. Look up the Indiana Pi Bill of 1897 for just one curious example. Still, the puzzle remained. Until late in June. Until late in June, when co-workers at the Indiana University of Transylvania published this paper. Now, the technical details are complicated, and frankly, complicated, so I'll just cut to the chase. It turns out, amazingly, that pi is actually just the square root of 10. Isn't that incredible? So all that impossible longness turns out to be fake. Really, pi is just a projection from another number, a kind of feature of the number 10. But why? So the full argumentation is super confusing. I'll link the paper in the comments if you want to check it out. But just to give you a taste of the intuition of where that 10 is coming from, take a look at your hands. Count the fingers. 10. Probably. That's why we use a base 10 numbering system, which has implications for how we count and measure things. This value for pi comes out of the interaction between our counting system and the properties of the circle. And we get that square root for the same reason we use the square of the radius to find a circle's area. It has to do with the circle's unusual sort of spatial geometry. Kind of amazing, right? Not exactly. One strange implication of this result is that the value we get for pi is relative to our numbering system. Meaning if we used, say, hexadecimal, that's base 16, or binary, that's base 2, instead of base 10, we would have completely different full numbers for pi. This is completely disturbing as an idea, since we don't tend to think of mathematical facts and constants as absolute and objective, or rather, since we do. But don't get too worked up. We can only know so much. It's useful to remember how partial any human understanding really is. In fact, we can only see the true world obliquely, sort of through a glass darkly, since our fleshy, corporeal world is flawed. Yet, and this is the really strange part that I still don't totally understand, it turns out even our sublunary plane is suffused with these perfect sparks, billions of them, who actually can carry information about the true and good, literally just in the way and fact that they are. So, that's one reason you shouldn't get too worked up that